in the vast expanse of space, beyond the confines of our own solar system. Exocomet belts are intriguing structures that have recently captured the attention of astronomers. These belts, discovered orbiting nearby stars, are analogous to the Kuiper belt in our own solar system, but on a much grander, interstellar scale. The discovery and study of exocomet belts provide essential clues about the formation, evolution, and dynamics of planetary systems beyond our own, as well as the role these icy bodies play in the development of planets and moons. What are exocomet balls? Exocomet belts are collections of icy bodies or exocomets that reside in orbit around stars other than our Sun. These comets are composed of frozen gases, water, and dust, materials thought to be remnants from the early stages of planetary formation. The term exocomet balls refers to the individual cometary bodies within these belts. They are essentially large chunks of ice and dust, similar to the comets found in our own solar system, but they exist in distant regions orbiting stars light years away. Exocomets, like their solar system counterparts, are thought to originate in the cold outer regions of a stellar system. They are remnants of the protoplanetary disk, often thought of as dirty snowballs in space. These objects vary in size, ranging from small icy bodies a few kilometers in diameter to much larger ones. When exocomets approach their host stars, the heat causes the volatile substances in the ice to vaporize, creating the spectacular tails often associated with comets. These tails are composed of gas and dust particles that stream behind the comet, driven by the solar wind and radiation pressure. While many exocomets remain dormant in their belts, occasionally, they are disrupted by gravitational interactions with other objects or the gravity of their parent star, causing them to be sent toward the star and resulting in dramatic outbursts. These outbursts can result in the creation of observable comets that can be detected by astronomers. In some cases, the disintegration of these bodies can release enough material to form what could be seen as a brief, temporary cometary tail. Let's find out about the discovery and surveying of exocomet belts. The first evidence for the existence of exocomet belts came in the late 20th century. Astronomers studying stars in the nearby region of the Milky Way were able to detect signs of excess infrared radiation, suggesting the presence of dust and icy material orbiting around certain stars. This excess radiation could only be explained by the presence of cooler bodies, such as comets or asteroids, releasing heat as they absorbed energy from their parent stars. The most significant breakthrough in the study of exocomet belts came with the discovery of these belts around nearby stars. The European Space Agency's Herschel Space Observatory played a pivotal role in surveying nearby stars and identifying exocomet belts. Using its infrared capabilities, Herschel was able to peer deep into the cold regions of these distant systems and detect excess infrared radiation, indicating the presence of icy objects. One of the most notable studies came from the discovery of an exocomet belt around the star Beta Pictoris, one of the brightest stars in the southern constellation of Pictor. This star, located about 63 light-years away, was found to have a disk of gas and dust surrounding it, much like our own solar system's Kuiper belt, but far larger. The disk, discovered in the 1980s, is thought to be home to a significant population of exocomets. More recently, the Kepler Space Telescope has provided invaluable data on the characteristics and distributions of exocomet belts orbiting a diverse array of stars, with some of the most promising discoveries occurring within the so-called habitable zones of stars. Since the advent of these surveys, astronomers have cataloged over 74 exocomet belts around nearby stars. These objects have been detected at various stages in their evolutionary cycle, offering insight into how these belts form, evolve, and interact with their host stars. The study of exocomet belts continues to be an exciting and rapidly growing field of astronomical research, with new discoveries emerging regularly as technology and observational techniques improve. Now let's cover the age and distance of exocomet belts. Exocomet belts are generally found around stars that are similar to, or younger than, our Sun. The age of these systems varies significantly, ranging from relatively young, newly formed systems to older, more evolved stars. The age of an exocomet belt can provide crucial information about the evolution of the planetary system in which it resides. For example, the exocomet belt around Beta Pictoris is thought to be relatively young, estimated to be around 10 to 20 million years old. This suggests that the belt is still in the process of formation, with many icy bodies still accumulating and colliding. On the other hand, some older exocomet belts are found around stars that are billions of years old, such as the system surrounding the star HD 141569, which is approximately 100 million years old. These older systems have had more time to evolve and may display more dynamic behaviors, such as the disruption of cometary bodies and the creation of dust clouds. The distance of exocomet belts from their parent stars is also highly variable. Some of these belts reside far beyond the so-called habitable zone of their stars, where temperatures are too low for liquid water to exist. These cold, distant regions are akin to the Kuiper belt in our solar system, and are thought to be composed primarily of icy bodies. Other belts may be closer to their stars, residing within the habitable zones where conditions might allow for the existence of liquid water on surrounding planets or moons. Distances to exocomet belts range from as close as a few astronomical units, AU, from their parent star, to several hundred AU. For reference, 1 AU is the distance from the Earth to the Sun, about 93 million miles, 150 million kilometers. The size and distance of these belts give astronomers clues about the processes that govern the formation and evolution of planetary systems. It is believed that the outermost regions of planetary systems are populated with comets and icy bodies, which can be influenced by the gravitational forces of nearby planets, leading to the formation of these belts. In the evolution of exocomet belts, the evolution of exocomet belts is a dynamic process influenced by a variety of factors. Like the Kuiper belt in our solar system, exocomet belts can be shaped by gravitational interactions with nearby planets or other massive bodies. Over time, these interactions can cause some comets to be flung outward into interstellar space, while others may be pulled inward toward their parent stars, where they are eventually vaporized. The age of a star can also influence the evolution of an exocomet belt. In the early stages of a star's life, a great deal of material is still present in the form of gas and dust, which can form the raw building blocks of these icy bodies. As the star ages and the material in the system is slowly dissipated or incorporated into planets and moons, the number of comets in the belt may decrease. For example, younger systems tend to have denser exocomet belts, with more active comets, while older systems may exhibit fewer comets, with the material in the belt having been depleted over time. A key factor in the evolution of exocomet belts is the presence of giant planets. In many planetary systems, the gravitational pull of large gas giants can destabilize the orbits of smaller bodies in the outer reaches of the system, leading to the formation of scattered exocomet belts. These interactions can lead to the migration of comets, causing them to collide or be thrown out of the system entirely. The presence of exocomet belts around a star can also offer insight into the potential for life elsewhere in the universe. While these icy bodies are not directly related to the habitability of planets, they are thought to be essential for the development of life. Comets and exocomets may deliver water, organic compounds, and other essential building blocks to planets in the habitable zone, much like how comets are thought to have contributed to the origins of life on Earth. To conclude, the discovery of exocomet belts around nearby stars has opened up new avenues for the study of planetary system formation, evolution, and the potential for life beyond our solar system. The 74 known exocomet belts surveyed thus far provide an exciting glimpse into the dynamic processes at play in distant stellar systems. By studying these icy bodies and their evolution, scientists hope to uncover more about the history of the cosmos and the possibility of life elsewhere in the universe. As technology advances and observational tools continue to improve, astronomers are likely to uncover many more exocomet belts and gain deeper insights into the fascinating processes that shape distant planetary systems. The study of exocomet belts is an exciting frontier in astrophysics, one that promises to reveal much about the origins and evolution of the universe.